Isang maaliwala sa Tuesday sa ating lahat at I welcome you po to another episode of Chemistry Tidbits, Bite-Sized Chemistry Concepts. Sa episode po na ito, yung pag-uusapan po natin would be all about classical versus modern analytical chemistry. I-differentiate natin kung ano nga ba yung classical versus modern analytical chemistry at magbibigay tayo ng mga different applications. In this lecture video, yung outline ng pag-uusapan natin would be starting from the introduction to analytical chemistry, and then classical analytical chemistry, modern instrumental analytical chemistry, and some enumeration of the other applications of analytical chemistry. So tara, simulan na natin.
Okay, so bilang pambungad sa ating lecture video ngayon ay isang tanong. Have you ever thought what's inside your water? Well, the pure form of water is made up of H2O, but the water present in nature is oftentimes a mixture. Water, most of the time, is a complex mixture with other non-H2O constituents, gaya ng minerals and ions, maybe other organic matter. Pero, paano ba natin nalalaman kung ano ba yung ibang contents ng water? Well, dito na papasok ang larangan ng analytical chemistry or tinatawag nating suriing kapnayan sa Filipino. Ayon sa isang pag-aaral ng contents ng bottled mineral water sa Malaysia, ang mga samples ay nagtataglay ng calcium, bicarbonate, sodium, chloride, potassium, sulfate, magnesium, and fluoride, and silicon. Some of the other non-H2O constituents na makikita natin in drinking water. May mga minerals naman at ions at recommended levels, of course, that are good for the body. Now, let us define analytical chemistry. It is a branch of chemistry that let us ask what is something made of. It lets us know the identity and the quantity of the components. In a more technical definition, according to American Chemical Society, analytical chemistry is the science of obtaining, processing, and communicating information about the composition and structure of matter. If you can see here in the image, yung saklaw ng analytical chemistry is linked to other disciplines like in biology, physics, engineering, medicine, material science, agriculture, environmental science, geology, and even social sciences. Ito ay dahil yung main gist talaga ng analytical chemistry is about chemical analysis, which is very essential sa iba't ibang larangan ng siyensya. Analytical chemistry can basically be categorized into two main parts, the classical and the modern one. Classical analytical chemistry or classical methods of analysis involves total analytical techniques based on mass and volume. Dito nakapaloob yung gravimetry and titrimetry. Pag sinabi naman nating modern, ito yung mga makabagong pamamaraan gamit ang mga sophisticated na mga instruments. Dito napapaloob yung spectroscopy, chromatography, and a lot more. Now, this field is napakalawak talaga. Kasi, if you're going to study analytical chemistry in college, it would require you at least 2 semesters to cover most of the topic, but still not all. So, with that, yung tatalakayin lang natin ngayon is yung basic concepts. Since meron tayong iba't ibang level ng audience, kailangan nating i-define yung mga important terms para maging mas malinaw sa lahat. We have analyte, which is the compound of interest. Kung ano yung hinahanap natin, kung ano yung kina-quantify natin. We have the matrix, other components in the sample other than the analyte. So, tanggalin mo yung analyte sa sample mo, yun yung matrix. Titrant is a solution of known concentration in the burette. So, yun yung kadalasang nilalagay sa burette. Titrant naman, solution being titrated, contains the analyte. Pag sinabi natin titrant, yun yung nasa Erlenmeyer kadalasan. When we have equivalence point, it is the point in titration where amount of the added titrant is equivalent to the amount of analyte. Ang sinabi naman nating endpoint, point in titration when physical change occurs associated by chemical equivalence. Pag sinabi naman nating indicators or indicator, yun yung mga reagent na nilalagay to cause color at specific pH ranges. Now, unahin na natin yung classical analytical chemistry or classical analytical methods. So, unahin na natin yung classical analytical chemistry or classical methods of analysis. Before we introduce the general specifics, I would like to highlight some of important basic concepts from general chemistry. Types of reactions, balancing chemical equations, and most importantly, stoichiometric relations and calculations. Kasi ito talaga yung magiging basis ng numerical analysis mo with, say, the quantity of compound A to compound B. Now, let's kick it off by starting with gravimetry. So, when we say gravimetry, these are quantitative methods that are based on mass measurements or change in mass measurements. Basically, we do have two common gravimetric techniques. We have precipitation gravimetry and volatilization gravimetry. When we say precipitation gravimetry, from the word precipitation, the analyte is precipitated out from the sample and is converted to a weighable compound with known composition. Just like in the visualization for precipitation gravimetry, you have a sample and then you add the precipitating agent. Dito natin maka-highlight kasi yung concept ng solubility constants. Kailangan nating ma-understand yung ano lang yung mga ions na kung magre-react sila, magkakaroon ng precipitate or magkakaroon ng mga insoluble inorganic matter in your setup. So, in this case, nagre-react yung silver with a chlorine to form silver chloride. Then yung silver chloride nag-precipitate. So, pwede mo na lang i-filter yung silver chloride from the sample. And then, you dry it and you weigh it. When we say volatilization gravimetry naman, the analyte is converted to gas of known composition. Visualization, you have a sample here. Just like in this, as shown in this visualization, you have a sample, you weigh it, you apply heat to dissipate the analyte, you weigh it again, you subtract the before and after to determine the mass of the analyte. So an example of precipitation gravimetry is the determination of chloride ions in water. So as part of a brief procedure, you have to do sample preparation, addition of silver nitrate, heating and then cooling up of the setup, filtering of silver chloride, drying of silver chloride precipitate, weighing of silver chloride precipitate, and stoichiometric calculation. Just like what I said in the introduction of classical analytical chemistry, we do really have to have a good command of types of reaction, stoichiometric calculations, and chemical equation balancing. So, as you can see here, yung nangyayari talaga dito is that we have chloride ions in the water, we add silver nitrate para magkaroon ng single displacement. Mag-react yung silver at yung chloride to form silver chloride, and then since yung silver chloride is insoluble in water, magkakaroon ng precipitation. For volatilization gravimetry naman, determination of water of crystallization in magnesium sulfate times XH2O. As part of this brief procedure, ganito yung mangyayari. You do setup preparation, you do heating of magnesium sulfate in crucible using tripod, Bunsen burner, or oven, just like in the picture, cooling of crucible with sample and desiccator, weighing and reheating and recooling until constant weight is achieved, and then do stoichiometric calculations. Hindi talaga mawawala yung stoichiometric calculations. That's the very backbone of analytical chemistry. What we're doing in this determination is that we have magnesium sulfate kasi that are hydrated. When we say hydrated metal salts, sa crystalline structure ng solid na mga metal salts na to, may mga naka-occlude na mga water molecules which is in uniform number. So yung gagawin natin is we apply heat to release the water from the crystal structure, and in the end, we would know kung ilang water molecules ang nakapaloob in the crystal structure. Now, dumako naman tayo in titrymetry. When we say titrymetry, it is based on the volume of the solution of known concentration that is needed to completely react with the analyte. So yung kanina, gravimetry based on mass, Yung titrimetry naman is generally based on the volume of the solution. We do have three common types of titrimetry. We have acid-base titrimetry, complexometric titrimetry, and redox titrimetry. So as you can observe, yung difference lang nila is in the type of reaction involved, no? So when we say acid-base titrimetry, from the word acid-base, it is devoted to various types of neutralization, reaction in which the analyte and the tritron undergoes acid-base reaction. Pag sinabi naman natin complexometric titrimetry, it involves adding of complexing reagent, involves the formation of a complex from ligand in the metal analyte. When we say redox titrimetry naman, it involves analytical reactions that make use of redox reactions or electron transfers. As an example, for acid-base titrimetry is the determination of acetic acid in vinegar. So yung determination ng acetic acid pala in vinegar is very important, ano? Kasi you have to have the right amount of acetic acid, the right amount of concentration of acetic acid in your vinegar para safe siya for human consumption. As part of its brief procedure, you do sample preparation of the titrans, standardization if needed, adding of the most appropriate indicator, then dispensing the base, sodium, in this case sodium hydroxide, to each flask with sample vinegar until endpoint, record the volume to arrive at the endpoint, and then stoichiometric calculations. So what's really happening in acid-base titrimetry in this case is that you have the acetic acid reacting with your sodium hydroxide. So what happens when an acid and a base react with each other? They form salt and water. As an example of complexometric titrimetry is the determination of hardness of water, magnesium and calcium ions in water sample. So as a brief procedure, you do sample preparation of EDTA titran, dispensing of EDTA tritran. Yung EDTA is the short term for ethylene diamine tetraacetic acid. Until endpoint and recording of the volume and do stoichiometric calculation. What really happens in this titrimetric technique is that you have calcium and magnesium ions in your water sample, right? You put EBT or Ericom black tea as the indicator because that is the most appropriate indicator to be used in the pH range. And upon adding of the buffer and the EBT, it become wine red in color. Then you do the EDTA titration and then if you arrive at this color, then you reach the endpoint. For the redox titrimetry naman is determination of vitamin C in commercial tablets by iodometric method. So as part of the brief procedure, you do sample preparation of titrant and starch indicator, standardization of the titrant, dispensing of the titrant until the endpoint and recording of the volume, and then do stoichiometric calculations. Yung nangyayari dito sa picture is that this is already the endpoint and then this is just an overrun to validate if you have really reached the endpoint now already. Now, dumako naman tayo for modern or instrumental analytical chemistry. One of the main reasons of the emergence and development of modern analytical chemistry is to cater problems that classical analysis cannot solve, especially in sensitive identification and quantification of analytes in complex samples like blood, urine, plant extracts, and others. The instrumental analysis nowadays is the go-to gold standards for chemical analysis. Before we proceed with the discussion, I would like to lay down some of the important basic concepts when you're studying modern and instrumental analytical chemistry, which are the following: energy absorption and emission, electronic transitions, bond polarity, difference in electronegativity, molecular geometries and structures, intermolecular forces of attractions. So when we say modern instrumental analysis, yung chemical concepts like spectroscopy, chromatographic separation are incorporated to sophisticated and specialized instruments for easier and more efficient measurement of the analyte compared to classical methods. The analyte is characterized based on the instrument's signal measured, which provides data on, for example, absorption, emission, transmittance, retention time and peak area, chemical shifts, etc. The values from these can be translated to concentration of analyte or analyzed to provide the structure and identity of the atoms or compound. Some of the common spectroscopic techniques are atomic spectroscopy, This is the actual image of the instrument, which is being applied in the analysis of heavy metals from plants, soil, water, and food. The main concept of atomic spectroscopy is based on the fact that when you shed a continuous spectrum to an atom, it has a unique emission spectrum and absorption spectrum, which you can use to identify that certain atom, and you can use the instrument signal in the quantification of those atomic species. Now, we also have UV-vis spectroscopy, which involves the measurement of absorption of the sample. Basically, what happens here is that you expose the sample in a beam of UV-vis, and then the sample will absorb some of the specific wavelengths depending on what chromophores is present in the molecule. One of the applications of UV-vis spectroscopy is the analysis of benzoic acid in beverages. We also have IR spectroscopy, which involves shining IR radiation to the sample, in which the sample would absorb some of the IR radiation and would cause excitation of molecular vibrations and rotations. So basically what happens here is that you direct an infrared beam to the sample, and then the molecules in the sample would be excited through vibrations. Now, the beam is then absorbed at a specific energy of vibration and loses its intensity at corresponding wave number. One of the applications of IR spectroscopy is in drug and food fraud analysis. Still under modern and instrumental analytical chemistry is chromatography. So we do have two common types of chromatography, gas and liquid chromatography. So basically, when we say chromatography, it's just synonymous with separation of the different components in a sample enabled by the different interactions within the column. So when dealing with chromatography, we have to be acquainted with the concept of mobile phase and the stationary phase. So when we say mobile phase, siya yung gumagalaw from the start of the column to the end of the column. Siya yung magdadala ng sample mo from the start to the end. Now when we say stationary phase, siya yung mga molecules na naka-attach to the column, which would have an interaction with your sample and would enable the separation of the analytes in the sample. Now, the principle of separation is based on the interactions in the stationary phase. So, kung sino yung analyte na may less interaction with the stationary phase in the column, siya yung unang lalabas. Kung sino naman yung mas maraming interaction or mas stronger yung interaction with the stationary phase, yun yung last na lalabas. So in gas chromatography, you inject the sample in the injector, and then the sample will be pushed by a carrier gas to the column, and this is what's happening in the column. The sample gets separated into its different analytes, and then would be detected in the detector, and then would be expressed as a chromatogram in the readout in the PC, which is kung sino yung unang lalabas in the column, siya yung magre-represent ng first peak, ng second peak, and then so on and so forth. We also have high-performance liquid chromatography, which uses the same idea with gas chromatography, but different lang yung phase ng kanilang mobile phase. Like in liquid chromatography, solvents yung ginagamit as mobile phase. The same is happening. As you inject the sample gets separated into its different analytes and would be reflected in the chromatogram of the sample. HPLC is applied in the analysis of non-volatile compounds such as in drugs and beverages, etc. Now, we also have other analytical instruments being used in the lab. We have nuclear magnetic resonance spectrometer, which is used to determine the connectivities of atoms in a molecule, especially organic compounds. We also have thermal gravimetric analyzer, which is used to determine the thermal properties of a compound. And we also have mass spectrometer, which is used to determine the mass of the ions. Some of the application of instrumental analytical chemistry as a whole is in environmental monitoring, in food and plant analysis, and in multi-omics technologies, like in the analysis of the DNA, the RNA, the proteins, and the metabolites, which is collectively termed as omics technologies. So as a summary, we have discussed about classical and modern instrumental analytical chemistry. In classical, we have techniques including gravimetry. In modern naman, includes spectroscopy and chromatography. In classical, gravimetry is based on mass, and tachymetry just generally based on volume measurements. In modern instrumental naman, measurement of analyte is based on instrument signal like absorption, transmittance, emission retention time. In classical, it's generally cheaper method of analysis but less efficient given a lot of labor and is less used today. The modern instrumental naman is more efficient and is of wide applicability but generally costly. So that concludes our discussion for today. I hope you learned a lot from this discussion. Muli, ako po si Jason C. Alcano, isang chemistry intern dito sa PhilSci Hub, and this is Chemistry Tidbits, Bite-Sized Chemistry Concepts.